us. He's one of the project leader for Owasp API Top 10. He started his career in a red team in a government organization for 5 years. Then he moved to Silicon Valley to learn more about the startups, modern applications, and APIs. And today he will provide consultation and he'll provide his recommendation on API security, that how we can actually have API security in place. So over to you, Inon.
Thank you so much. And this is my pleasure to be here. I was actually planning to visit in India right now in May. The coronavirus kind of changed my plans. So it's very exciting to be here on this meetup. Yeah, so my name is Inon Shkedy. I'm one of the co-leaders of the Owasp API project. And today I'm going to talk about the Owasp top 10 for APIs and about like what has changed between traditional to modern applications, and give you some tips as pen testers and developers how to break and protect APIs. Let me share my screen. Can you see it? Great.
Yes.
So 1 second. Yeah, so the agenda for today is to talk about modern application security issues, things like SQL injection, cross-site scripting, CSRF, and more boring stuff. No, I'm just kidding. All of these things kind of belong to the past. Today, we're going to talk about modern application security issues to see relevant examples from the recent time. And we are going to try to understand what has changed in the field of application security. I mean, before we jump into applications like API security, I want to explain what has changed. What is the differences between traditional applications into modern API-based applications? So just a few words about myself. I'm the head of security research at Traceable AI. We are doing something in the field of API security, but we are still in stealth mode. I got 8 years of experience with application security, and I have grown up together with APIs. So what does it mean? I started my career back in Israel. I used to be part of the red team of the Israeli army, which is the IDF. And I had a chance to break into many systems in the field of government, military, and financial. As you could imagine, those systems are based on traditional technologies. I saw a lot of Java, ASP.NET, SAP, and very old concepts like multi-page applications, on-prem environments, waterfall deployment, and APIs used to be just a niche component, mostly for B2B communication. After 5 years in the Israeli army, I decided to buy a one-way ticket and to move to California. By the way, it took me like 5 hours to create this animation. You should appreciate that. Yeah, so basically after I moved to Silicon Valley in California, for the last 3 years, I've been working mostly with startups and tier 1 companies. And I got exposed to a new field of frameworks and technologies like Ruby on Rails, Node.js, Elixir, and very modern concepts. For example, single page applications, cloud environments, CI/CD, and the most important part, all of these applications are deeply based on APIs. APIs are no longer just a niche component for B2B communication. Today, APIs are the backbone of the application. And you know, the next thing I figured out is that I couldn't really use my old ways. Like back in the days in Israel, I used to find many like SQL injection, cross-site scripting, and all this stuff. But if we're talking about modern API-based applications, they're becoming less and less relevant. So I had to adapt my mindset and the way that I perform pen tests in order to stay relevant in this field. Because I didn't want to go back to Israel, I wanted to stay in the Silicon Valley. So I had to adapt myself to this new reality. And today I'm going to talk about some of the conclusions. And I mean, this is the main reason why I joined the Owasp API project. So before we even talk about API security, I want to talk a little bit about what is the difference between traditional applications into modern applications. So if you look at the screen, you can see an example for a very traditional application. This is the Yahoo homepage from 2010. And this is some type of a multi-page application. Every time you click a new link in the app, you get into a new HTML page. It's basically a new URL. And today, this is an example for a modern API-based application. This is Google Drive. All of the components are on the main page. Everything behind the scenes is API. I mean, if you compare these two views, these two applications, you might still use your mouse and keyboard, but behind the scenes, everything is very different. So, I mean, there are many changes. If we compare traditional and modern applications, I'm going to provide you some type of a high level, mostly for components that are relevant for security. So let's start. Back in the day, you could see a pretty simple flow between the client and the server. The client would ask for a specific web page, for example, home.jsp. Then the web server would fetch data from database. Usually it was SQL. Then the web server would take this data and render a visual page. I mean, when I'm saying a visual page, I mean HTML page with CSS and JavaScript. And then the web server would return this visual page to the client as an HTML page. And the browser would present this HTML page to the client. It was pretty simple. Today, it's very different. First of all, clients know better what they want. They ask for specific pieces of information. They would ask for the web server from the API, for example, give me the last 20 notifications, or give me this specific user details. They don't ask for full complete HTML pages. They ask for pieces of information from the API. And then the API, the web server, basically fetch data from databases. And by the way, today there are more types of databases. You can find the old traditional SQL, but you can also find NoSQL or Elastic. And then the API basically take this data and return it to the client as a JSON file. And the main difference between HTML to JSON is that JSON contains raw data. And then the client takes this raw data in the format of JSON files and render a visual page to the user. So back in the day, the rendering component was on the backend. Today, it's on the client side. And this is one of the most important changes in modern applications if we talk about security. Yeah, so let's talk about a few more changes. If you're talking about the clients, you can find more types of clients today. Like together with the traditional browsers, you can find IoT devices, you can find mobile devices, and also you can find developers that use our APIs to develop their own applications. And also, clients today are much more powerful. Your mobile device, your iPhone or Android, they are very powerful. And this is the main reason why the rendering component moved from the backend to the client, just because client has more resources and they can take responsibilities from the servers. Another very interesting example is that today there are less abstraction layers. Why? Because today clients, servers, and databases, sometimes they speak the same language. All of them speak in JSON. I mean, in the case of client and servers, they always speak the same language, which is JSON, and sometimes also databases, in the case of NoSQL. So it's kind of an interesting situation because today, if your browser is processing some type of JSON, like the JavaScript in your browser process some JSON, it might be the same representation of the same JSON on the API on databases. So basically, today it's much easier to understand the underlying implementation of the application just by looking at the traffic. There are less abstraction layers. A few words about DevSecOps. So there is bad news and good news. Let's start with the bad news. So, I mean, sometimes it feels that it's too easy to do DevOps. Like you just click a few buttons on the AWS console and you can spin up a new API, you can spin up a new service, and it makes it really hard to keep on track with your APIs. It leads to a situation like shadow APIs. Many companies today don't really know exactly where are their assets. They don't know about all of their APIs or all of their API endpoints. And the good news is that many of the classic IT issues like open ports and old versions barely exist in modern applications. Why? Simply because the cloud providers protect you against these things by design. And in terms of application security, the good news today is that many of the traditional vulnerabilities, like SQL injection, for example, many of them are solved by design. So if we're talking about SQL injection, for example, you can see that today APIs are not very vulnerable to SQL injection. I mean, I'm talking about the modern types of APIs, modern applications. Why does it happen? It's because developers use ORM environments. And do you know what's the reason the developers use ORM? I'll give you a hint. It's not because of security. They usually don't care about security. It just makes it much easier to use. It's much easier to use ORM instead of native SQL. But in most of the cases, ORM solves the problem of SQL injection. If we talk about CSRF, today many developers choose to use authorization header instead of cookies. And if you use authorization header instead of cookies, it solves CSRF by design. If you're talking about cross-site scripting, it's still a thing, but today clients are responsible to protect against XSS. Why? Because servers return JSONs. They don't return HTML pages. If we talk about path manipulation, like directory traversal, they are much less severe in most of the cases and much less prevalent. Why? Because today developers use cloud-based storage like S3 on AWS. And last but not least, XXC, which is a vulnerability in the parsing process of XMLs, doesn't really happen today because developers use JSONs and not XMLs. The bad news about APIs and modern applications is that today the attack surface is much larger. Why? Because APIs expose more entry points. Instead of exposing only one web page of home.jsp, today in order to get the details for the same view of like the homepage of the app, the client performs like 5 or 6 different API calls to fetch notifications, to fetch your profile, to fetch the last messages. So every view in traditional applications becomes multiple API endpoints in APIs. And it basically makes the attack surface larger. The second point is that today APIs are oversharing. As we talked about, APIs basically expose the underlying implementation of the app. If you look at the traffic, if you look at the JSONs that you receive from the APIs, you can understand much better what the developers want to do just from looking at the traffic. And it's a very interesting point for pen testers, by the way. It makes it much easier to perform pen tests. And the third point is APIs are much more predictable. The REST standard and the API economy, they encourage developers to develop APIs in a very predictable and structured way. Why? Because it's much easier for developers to use your APIs. If you're talking about the front-end developers or B2B, like or other developers that use your API to build their own applications, it's much easier to use your API if it's easy to predict how to use it. For example, if you change the HTTP method from get to delete or post, you get a new endpoint. You get like a new function. So it's much easier to use the API today, and there are more entry points, but it exposes the application to more security risks. So, I mean, after I see all of these things in the field of modern applications, it led me to join Erez Yalon from Checkmarx. He's the director of research in Checkmarx, and we started working on the Owasp API security project. The goal of the project, there are many goals, but the first goal was to define the top 10 threats for APIs. Basically to understand exactly what has changed. What is the difference between like the Owasp top 10 2017, which talks more about traditional applications, and to compare it to modern applications. So what we have done is it was a process of like about 10 months to create the first version. We have reviewed many bug bounties reports and the APIs breaches from the recent time, like for example, Equifax, Uber, Facebook, and many other breaches from the recent time. And we try to understand also, of course, by involving the amazing Owasp community, we try to understand what has changed in this field and to define a new list that defines the top 10 threats. So this is the list, and I'm going to talk about each one of these vulnerabilities briefly. And before I do it, I want to talk with you about the biggest challenge in APIs, which is access control or authorization. I mean, if you take a look at the Owasp top 10 for APIs list, you can see that many of these issues have something to do with authorization. If we talk about broken object level authorization, or excessive data exposure, or a broken function level authorization, or mass assignment, each one of them had something to do with access control and authorization. So, you know, it kind of led me to think, what's the reason that authorization became such a big deal in APIs? And I believe there are two main reasons why it happens. First of all, if you think about it, authorization, it's not just one component in the app. It's very different than authentication, for example, because authentication you implement in one place or maybe a few places, but then you can kind of forget about it. If you use the best practices, if you did it right, you can assume it's pretty secure. But if we talk about authorization, it's very different. It's a very spread out mechanism. You can find authorization in almost every part of the application. If we talk about the object level authorization, it's in the code itself, and basically every controller in the code that receive input from the user that contains IDs need to implement authorization checks. If we talk about function level authorization, it's something that can be done in the code level, in the configuration level, and sometimes even in the API gateway level. So it's not just one component, it's very spread out. And every time you write a new code, you need to make sure the code performs authorization checks. And then the second point, which is even more interesting, is that today in modern applications, you can find many types of users and roles. And it creates kind of interesting situations. Like for example, this is some type of ride sharing app like Uber, and you can see that you have the groups of riders, drivers, and admins. And then you can find a user like Hugo that has two sub-users, or one user like Jack that belongs to the drivers group and also to the admins group. So it makes it very challenging to keep policies for these types of users. Let's jump into the number one vulnerability in APIs, which is broken object level authorization. You probably know this vulnerability is IDOR, which is insecure direct object reference, but we changed the name from IDOR to BOLA. Because IDOR, it's a cool name, but it's not very accurate. It's not very relevant to what we are trying to describe. Yeah, so let's talk about what is a broken object level authorization. In order to do it, I'm giving an example of a very modern app, which is a ride-sharing app. The name of the app is not Lyft. And let's say that you took a ride, and the ride was very nice, and you want to rate the driver and to give the driver 5 stars. So after you take the ride, you click on the 5 stars icon on the app, and then behind the scenes, your mobile client sends an API call to post/API/trips/rate trip in order to rate this trip or a ride. But the problem is that you've taken many rides on this ride sharing app. And the API can't really know which ride you want to access and to provide rate for. So your mobile client has to mention the trip ID as part of the API call. In this case, the trip ID is 718492. And then the developers on the backend, they say, okay, I'll just take the ID from the request, and I will update the object on the database based on the ID provided by the client. It's a very easy way to implement this mechanism, but it opens the door for broken object level authorization. Why? Basically, because the developers don't check that the user has access to the object represented by the ID sent in the request. And if you think about it, as an attacker, I could easily write a script to enumerate all the trip IDs and to send, like, let's say, 1 million API calls to update all the trips with the rating of 0. And I would be able to update all the trips on the app with 0 rating, even though I didn't take all the trips. So this is broken object level authorization, and there are many ways to exploit it. And to be honest, if I could, I would define this vulnerability as number 1 and also as number 2. This vulnerability is so severe and so prevalent in APIs that almost company that I've tested is vulnerable to this issue. So there are 2 types of BOLA. One of them is based on the user ID, and it's kind of easy to protect against this type of vulnerability because you can just, on the code level, you can just compare the user ID that's sent from the client in the parameters to the current user object and to see if it's the same ID. So the protection is kind of straightforward. But then there is the second type of broken object level authorization, which is based on object ID. And by saying object ID, I mean every object which is not the user. So this is a bit more challenging, and it very depends on the business logic of the app. Let's say that you take a trip with a co-rider, like you, for example, you take an Uber pool. So because you are like there are 2 people, 2 users that take the same trip, both of them should have access to the trip object. So it's not just comparing the current user ID with some parameter, it requires more logic to understand which users took which trips. So what is a good authorization mechanism? How can you implement and how can you test that the system is protected against this type of vulnerability? So there are 2 main components for the authorization mechanism. The first one is complex and has a lot of logic, which is the decision engine. This engine should be a very smart piece of code or library or microservice that knows to answer every authorization question that your developers might have. And then the second part is on every controller that you implement, you need to use the decision engine. So let's see a few examples. In this case, we have user number 585, and this guy is trying to update the profile. He's trying to access the endpoint of post/update profile, and then he provides the user ID of 616 in the body of the API call and the new email. He's trying to update the email for this user. So do you think it's a legit behavior? Because this is 585 and this is 616. So the answer is, I don't know. It really depends on the business logic of the app. Maybe user number 616 is a sub-user of 585. Anyway, the developers that write the profile controller have to check with the decision engine if this user has access to this object ID. And this is how you create a good authorization mechanism. It's very important to kind of separate these two components, because many times the developers that write the logic of the profile controller, they don't really know everything about the app. They don't really know all the components or all the microservices of the app. So they just need to use functions that was written as part of the decision engine. And usually what I see in companies, that the decision engine is a component that is written by very experienced engineers that know all the components of the app. Let's see a few more examples. We have user 232, and he's trying to access receipt number number 777. So the developers who write the receipt controller need to check if the user has access to the receipt. And in this case, it can be kind of complex to figure it out. And this is a logic that should be done on the decision engine. Because if you took a carpool or like some type of Uber pool, you might have access to a receipt that another user also has access to it. It's not like just like a very simple and straightforward relationship. It's a bit more complex than that. Oh, let's take, for example, this admin. Admin number 616 is trying to delete user number 888. But the problem is that admin 616 is from California, and he's a regional admin. He should be able only to edit the details of users from California, but user 888 is from New York. In this case, the admin panel controller, the developers that write this controller, need to check with the decision engine if the admin should be able to delete this user, and then the decision engine, based on the business logic of the app, should return true or false and to block this guy from deleting the user. So, one of the questions I ask myself is why BOLA is so common in APIs? The main reasons is because today you can see more IDs are sent from the clients to the API. The REST standard encourages developers to send IDs in URLs. And I mean, in most of the cases, when I performed some type of pen test for an API, the application does have part of the authorization mechanism. Usually developers do create this type of decision engine, but many times the problem is that the developers that write the controller's logic don't use the decision engine. They just let the user to access a random ID. This is just a cool example from the recent time. It was found by Anand Prakash from AppSecure, and he managed to find a full account takeover on the Uber API. So you can take a look at this API call to get consent screen details function. And as part of the API call, you provide the user ID, and the response contains all the details about the user. You can see the email address and the country, but the most interesting part, the API actually return the access token to the user. So Anand could potentially enumerate all the user IDs on Uber and to get access tokens to all of them. And I think it's a very interesting example because Uber is a very large company and they have a great security team, but you can see that even these type of companies are vulnerable to BOLA. Let's jump into the second vulnerability, the second issue in the Owasp top 10 for APIs list, which is broken user authentication. Broken user authentication is actually two types of vulnerabilities. The first one is lack of extra protection. So if you take a look here, you can see that we have an API that exposes 4 API endpoints: update picture, get location, web login, and forgot password. So the get location and update picture are not very sensitive. They have nothing to do with authentication. So you could rely on your rate limiting mechanism. For example, many companies use Cloudflare, for example, in order to protect those two endpoints. But then when we talk about authentication endpoints, and by saying authentication endpoint, I mean every endpoint that has something to do with authentication. It doesn't have to be login. It could be forgot password or login using one-time token. So every endpoint that has something to do with authentication needs extra protection. And this extra protection is things like account lockout or a CAPTCHA or brute force or like protection against brute force attacks. So for example, if you are trying to log in to the same email, like with the same email, and you are trying to guess passwords, you should be blocked, for example, after 10 attempts. And this is not something that you would see in the rate limiting mechanism if we talk about get location, because get location is less sensitive. And the second part of this vulnerability is security misconfiguration in the authentication framework. One example is that JOT tokens allow algorithm to be none, and attackers can basically change the user ID in the JOT token and to log in on behalf of another user. And then another example is tokens that don't expire. There are many types of misconfiguration for authentication frameworks. I want to show you a different example for a full account takeover on Facebook. This is a good example for broken user authentication. It was found by Anand Prakash, the same guy from UpSecure. And what Anand found is an API endpoint to recover your account. And the process is pretty simple. You enter your phone number, and then you receive an SMS token with a token of five digits to reset your password. So he was trying to exploit this mechanism to guess the 5 digits token in order to get full access to another user. So he tried to do it on facebook.com, but they blocked him after 10 attempts. After 10 attempts, he wouldn't be able to guess more tokens. So it was secure. But then he tried the same pattern on beta.facebook.com and another API. And those APIs didn't implement this type of rate limiting. They didn't implement the extra protection part for authentication endpoints. And this way, he managed to basically get full access to all of the users on Facebook. One sec. So let's jump to API number 3, excessive data exposure. This is personally one of my favorite vulnerabilities. Instead of performing a complex penetration test, you can just look at the traffic and to see PII of other users. Why? Because APIs leak PII by design. It happens a lot in APIs. And if you think about it, it's kind of a unique situation. And it took me time to understand why it happens. Why APIs expose sensitive data of other users by design. And in order to understand this vulnerability, I'll give you some example from a dating app. So I live in San Francisco. Dating apps are pretty common. And you basically swipe right and left, and then you see the profile of Bob. So as you can see, like on this screen, nothing is sensitive. The API doesn't expose anything sensitive. But if you snip the traffic between the client and the API, you can find something very interesting. Let's take a look. In order to fetch the profile of Bob, your mobile client performs an API call to get /users/717. 717 is the ID of Bob. And then the response from the API contains a JSON with details about Bob. You can see Bob's name and hobbies and the profile picture. All of them are legit. All of them are shown to the user, and they're not considered to be sensitive. But then you can see the address of Bob, which is Gru's Mansion and in Evil Road. So, I mean, if you use the mobile client, you can't really see it. But if you snip the traffic, you can easily see the sensitive information. So filtering sensitive information on the client side is always a bad idea, but developers do it a lot in APIs. Why? It's a good question. I believe that the main reasons are that the API economy and the REST standard, they encourage developers to develop API endpoints in a very generic way. So many developers, many like front-end developers can use the APIs and they don't need to ask so many questions. It's very easy to use the APIs. So they just prefer to return like raw objects instead of filtering the parameters of each object that they return. Many developers use the functions like toJSON or toString from the ORM or the model itself. And I mean, in a more high level, the main problem is many times when developers write APIs, they don't think who is the consumer of the data, and they just prefer to return raw objects. A recent example from 3Fan app, it's basically an app that it was found by Alex Thomas from Pentest Partners. And this is a vulnerability that allows you to show details, to see details of other users on the app. A 3Fan app is some type of dating app, but it's a bit more unique. It allows couples to find other people that are interested to join them, basically for swingers. So let's take a look at the vulnerability. Alex found that the app, the mobile client, performs an API call to get/match users. This endpoint returns you all of the users in your area. And I mean, it's a legit endpoint because this is how dating apps work. But if you take a look at the response from the API, you can see like gender and other things that are not sensitive, but you can also see sensitive details about the user, including private photos that those users share with other users. The next thing that Alex did, it's very interesting. He basically wrote a script to map all the users of 3Fan app around the White House. Yeah, it's a very interesting use for this vulnerability. Let's jump into A4, lack of resources and rate limiting. It's a pretty straightforward vulnerability. In many cases, it might lead to a denial of service. Let's say that you have social network API, and then you have an endpoint that returns a list of users, and you can limit the amount of records that you want to receive from the API. And the regular users usually would send between 1 to 100 because this is the way that the front end work. But then an attacker is trying to send a very long value, like for example, 1 million or just a very long value, and it could cause the API work really hard in order to fetch all these details from the database, and it could crash the app. A5, another pure authorization problem. It's broken function level authorization, or BAFLA. And this is a kind of a cool vulnerability. Let's say that you have an API host that exposes 3 types of APIs. One of them is for admins, one of them is for writers, and one of them is for drivers. And then you have an admin that is trying to delete user number 717. This is a legit API call. Why? Because admins should be able to delete other users, right? But then what happens if an attacker that has just a writer account is trying to perform the same API call to the server to delete user number 717? What happens in many cases is that developers don't verify that the user who sent the API call actually belong to the admin group. And then you can find it basically leads to some type of privilege escalation that the user with no privileges can access endpoints that belong to different groups on the API. It's not a new vulnerability. You could find exposed admin endpoints also in traditional applications, but it becomes much more common in API. And as part of the creation process of the Owasp top 10 for APIs, we try to understand why. And One of the main reasons is it's much easier to detect and to exploit this type of vulnerability in APIs. Let's try to understand why. So let's take, for example, two different functions that application can expose. One of them is a non-sensitive function that every user should have access to, which is fetch user's profile. This in the case of traditional applications, it would look something like get/app/users view.aspx and then the user ID. And then let's look at another function of delete user. If we talk about traditional applications, it usually looks something like post/app/admin panel/user management.aspx. And then in the body of the request, you would need to mention the action or the user ID. I mean, this is just one example how developers might choose to implement this pattern, but my point, it wasn't easy to predict this entry point. It's really hard to predict like this type of like endpoint because you need to guess the URL, you need to guess the parameters. So even if the developers did not implement access control on this function, it was really hard to exploit it from the pen tester perspective. Fortunately, or unfortunately, it depends on your perspective, in APIs, it's very easy to predict the admin functions. Why? Because the REST standard encourages developers to develop APIs in a very generic ways, and you just need to change the HTTP method from get to delete, and you can find this admin function of deleting a user. Also, there are many ways to implement function-level authorization. It could be done in the code, on the configuration, and sometimes even in the API gateway. And there are many complex roles when it comes to modern applications. You can find admins, super admins, supervisors, and so on. Just one recent example for a broken function level authorization from Shopify. The security researcher UZ Sami got 20 grants bounty on HackerOne because he found a way to gain access to all of Shopify shops. How? Basically by accessing a function, API endpoint, that should be accessed only by admins, but the developers did not check the group of the user. Let's jump to MassAssignment. And in order to understand what is MassAssignment, I want to explain what used to be before MassAssignment. Let's talk about some type of create user flow in traditional applications. So you have a user and the user wants to create a user on the app. So back in the day, it would look something like that. The user would send to the entry point of create user, he would send the first name, the last name, and the password. And the application server, the developers would fetch each one of the request parameters and put it in a new variable, and then they would create a representation for the new user object and save it on the database. And this object would be saved on the database as part of the ORM framework. So this is fine. This is not vulnerable for MassAssignment. But as you can see, it requires you to write a lot of code. You need to fetch each one of these parameters from the client, like from the HTTP call, and to put it in a new variable. Today it looks it looks very different. If you take a look at this creation user process, in many cases you can see that the user would send something like post/users/create, and this is a REST API call. So inside the body of the API, you can see that you basically send a user object together with all the sub properties like last name, first name, and password. And then on the application server, instead of fetching each one of these objects and assigning them into a new variable, they use some type of black magic provided by the ORM environment, and they basically take the JSON and save the JSON as is as a new record on the database. It's very, very convenient from like developer's perspective. It saves you time. You don't need to write so many lines of code. You can just use one-liner, but it exposes, and developers really like to use it, but it exposes the app to many vulnerabilities. Why? Because they don't validate that the user has access to edit these properties. So let's see how you can exploit it. So you have this API call to API/user/new, and this is a legit use for this API endpoint. You just send the username and the password. But then a malicious use would be to send username, password, and role, and to try to assign yourself an admin account. This is not something that the developers intended to do. They didn't plan to allow users to assign themselves to the admin role, but because they use this one-liner, they're exposed to mass assignment. And if the developers don't check that the user actually has access or should have access to edit this property, the app would be vulnerable to mass assignment. So also about mass assignment, it's nothing new. It's kind of an old concept, but it's more common in APIs. Why is it more common in APIs? So it's easier to exploit mass assignment in APIs. And I mean, let's try to understand why. So if you think about mass assignment, it's nothing like SQL injection that you can just run some like SQL map or other like open source tools in order to exploit one specific SQL injection that you found. You need to be more creative in order to exploit mass assignment. There is not only one way to do it. And the problem with traditional applications is that they didn't expose so many details about the application itself. So it would be kind of challenging to be creative and to understand how to exploit mass assignment. Fortunately, in APIs, it's much easier to exploit mass assignment because you don't need to guess the properties of the object. So in order to explain this concept, let's say that you have some endpoint, put/v1/video/the video ID, and you know that this endpoint is vulnerable to mass assignment. It means that you can update or edit every property of the video object on the database. But you know only one, like you know that this API call should contain name. But so how would you exploit it as a pen tester? And to be honest, there is no one way. It depends on the implementation on the backend of the video. So back in the day, it would be very like challenging to understand how to exploit it. Fortunately, today in APIs, you can just find a get endpoint that returns all the properties of the video. So this endpoint of get/v1/user/video file returns all the properties of this video object. And if you take a look, you can find a very interesting parameter, which is conversion params. And by the way, this is based on a real example. I found it in some type of banking app. And what you can see here is basically the value of the conversion params. It looks like something that belongs to a shell command. It looks like something that would be add to a shell command. And the next thing I did is basically to create this payload. And using the mass assignment, I edited the conversion params property, and I basically exploited shell injection. As you can see, I mean, this is not the real payload I used. I used something more subtle like ping. But this is a good example for mass assignment because APIs allow you to understand better the properties of the application. And basically, in general, they allow you to understand the underlying implementation of the app. And you can leverage mass assignment to exploit underlying vulnerabilities. One example from a New Relic, it was found on New Relic. It was found by James Kedel from Portswigger. Users basically, like using MassAssignment, user can enable access for free access to the API. So there are two types of APIs on New Relic. There is the free API and the premium API. And if you send an API call to post/account/account ID, you could edit this allow API access to true and to get free access to the API. A7, security misconfiguration, is basically a bucket of bad things. You can find under this category many different problems that are relevant for APIs, like for example, hard-coded passwords, lack of CSRF or CRS protection, lack of security related HTTP headers, weak encryption, and more. Vulnerability number 8, which is injection. I want to talk about injection for a little bit. I mean, injection used to be number 1 in almost all the Owasp top 10 lists, but we decided to move it from number 1 to number 8. And many people asked me, why did you do it? So what I usually do is I ask them why injection was number 1 from the first place. And I believe that the main reason is because of SQL injection. SQL injection used to be kind of crazy back in the day. If you knew how to exploit SQL injection, you could basically gain access to almost every application on the internet. But today, SQL injections don't really happen in modern applications. It's not easy to find them, or like they barely happen. Why? Because developers use ORMs, and there is a huge market of security solutions and security products to solve SQL injection. And also, developers sometimes use NoSQL instead of SQL. And I'm not saying that NoSQL is not a thing, but usually it's much less severe and common. Let's jump to improper asset management. So if we're talking about this vulnerability, it's actually two categories of vulnerability. The first one is API endpoints that has no documentation. Many times you can find APIs that expose many endpoints, and most of them have documentation. Most of them, the developers of the app know exactly what functions they expose. But then you can find those shadow API endpoints. You can find some endpoints that the developers don't really know what they do, like VO/B2B/expose all users. This is some type of a legacy API endpoint that some developer wrote like a few years ago because one of the customers needed it like for now, but basically they forgot about this endpoint after that. And it's very bad because it doesn't matter if this API endpoint is vulnerable to other things like broken authorization or broken authentication. You need to know, and you need to know where are your API endpoints and to understand all of them. And then the second type of improper asset management is complete API environments or API hosts that nobody really know about them. These are the shadow APIs. So you can find like it's more like under the responsibility of the DevOps team. So they might know everything about payment API and mobile API. You know exactly who are the users, who is responsible for these environments. But then you can find this type of API host of QA-3-old, and nobody actually knows what is the purpose of this API. It's very common in modern companies, especially in the cloud, because it's too easy to do DevOps. It's just a few clicks and you spin up a new microservice, a new API to the internet. And it encourages developers to create many APIs, which is very convenient, but sometimes it makes it really hard to keep on track with these APIs. So why does it happen in APIs? Why is it so common to find those type of like lack of documentation or lack of API host inventory. One of the reasons it's because APIs change all the time because of CI/CD. You can find API endpoints, new API endpoints every day or every week. And as I said, the concept of cloud and deployment automation like Kubernetes, it makes it too easy to spin up a new API host. And this is what led to the situation. API number 10, insufficient logging and monitoring, is the same as A10 for 2017. It's a less sexy vulnerability, but it's very important to implement logging and monitoring. So if a breach has happened, you have all the resources to investigate the problem and to understand what exactly happened. Yeah, so this is the presentation so far. This is the Owasp top 10 for APIs. I'm not sure exactly how it works. Can they ask questions?
Yeah, absolutely. 1 minute. So someone is asking, can we get this PPT?
Yeah, definitely. I will share it with you.
Sure. So he'll share and we will share it further. So, and Vandana, okay. There was one point, there was someone mentioned that, can you explain in practically? Like, do we have any vulnerable app which we can test for API pen testing?
Yeah, it's a good question. I think Juice Shop of Owasp covers most of them. We are also working to create our as part of the Owasp API project. We are going to create a vulnerable API. It will be published in a few months.
Oh, that's great. Thank you. So let's give them some more time to ask questions because they're just going to type on the chat. That's how I'm going to
Right,
facilitate.
cool. I didn't know that YouTube provides you an option to perform live. This is interesting.
Yeah. So we generally do that almost every week. And so what we do is we actually take these questions on the YouTube live chat. And from there, we facilitate to the speaker so that the session is smooth and we can take as many questions as people have.
Cool.
So yes, now the questions are coming. So taking advantage, you are on OWASP API Sec project. Any updates on CR API project? How can I get involved?
CR API project?
Yeah.
Not sure if I heard about this project. What is the CR? Sorry.
That person just mentioned CR. That's all.
Oh yeah. It's it's crappy. It's a
Crappy.
completely
Yeah.
ridiculous API. Yeah. I'm sorry about it. Yeah. I mean, because of the coronavirus, the timeline changed a little bit, but we are planning to publish the first version of crappy in about 2 months, and it's gonna be pretty cool. Like the crappy is basically the vulnerable app I was talking about. And it's gonna be like a mobile app with many types of users, and it's gonna be vulnerable to all the OWASP top 10 for APIs. Yeah, so I see another question. Can you explain some injection attacks on API? Any bugs found on HackerOne? This is a good question. There are many injections on APIs, mostly when we talk about like more traditional APIs that were developed like, like 3, 4, 5 years ago. APIs are still vulnerable to SQL injection, to shell injection sometime. I can give you like a few tips how to exploit, how to find injections in API. I would recommend you first of all to find like the more niche endpoints, like endpoints that nobody like not many users use today. And also, I would recommend you to be focused on the like body parameters first. Usually, yeah, QRL parameters, like query parameters, tend to be more like less vulnerable. Any more questions?
So who are the vendors providing solutions for these problems? I think we wouldn't be able to share the particular vendor here because we are open source communities. We can share only
Exactly,
recommendations. Yeah.
exactly, exactly. But I just want to let you know that like the field of like API security is kind of complex, and many companies that do API security, they touch different fields of API security. So if you're reviewing a specific vendor, you need to understand like what the vendor is trying to solve. Any more questions?
Yeah. Actually, I'm just posting in the chat. So can you tell
Oh
me a
yeah.
bit more about the mass assignment vulnerability?
Um, yeah, I mean, mass assignment, it's something very common in APIs. I think the main reason why you can find so many APIs vulnerable to mass assignment is because modern environments like Ruby on Rails or Node.js, they kind of encourage developers to use this mass assignment feature. And the mass assignment feature is something inside the framework, like Ruby on Rails and Node.js and also PHP. They provide it to developers by design. It's like kind of best practices how to use these frameworks. It's not bad to use mass assignment, but if you use mass assignment, you really need to be careful how you use it. It's the same as using like native SQL inside your code. Like using native SQL, it's not bad as a concept, but you need to be very cautious that you don't concatenate input from the user without performing filtering. The same thing about mass assignment. It's kind of a risky feature. And like just in a few words, what is mass assignment? Basically, you take an object from the client as is. It can be some type of JSON that represents a user object, and then you just take this object and save it as is on the database. Like you just update or create a new record on the database based on the input came from the user. And in order to exploit it, you need to like you basically this type of situation allows you to edit or to update any property of the object that you want. In this case, the object would be the user object. And like one common like famous example for like well-known example for mass assignment, if we talk about users, is just to edit the group of the user and to assign yourself an admin user.
So, one more question. Can we expect
Mhm.
an API security testing guide the way we have for other projects? Like top 10 comes, then the whole testing guide comes. So in future, can we
Yeah,
expect that?
definitely, definitely. It's part of the roadmap. Yeah, I'm sorry it kind of got delayed. It's mostly because of the crazy situation with the coronavirus, but we will publish it in the next month.
And I think the people on the call who are listening, they can also contribute. So when they go to API security top 10 project or project this particular project, they can go to the code repo, go to GitHub, and start in providing the inputs because it's a community driven effort. Inon is the leader, and then Eris is the leader, but then community can come up with all the recommendations. That's how Owasp top 10 testing guide came into picture, mobile testing guide came into picture. So it's a community effort. If you feel that you can contribute or you want to contribute to it, please feel free to put your inputs on the GitHub, reach out to the leaders, and I'm sure they're more than happy to take your feedback and your inputs and embed in it into the API security testing guide.
Exactly, and
So
thank you so much for saying that. Like, I just want to say that the Owasp API product it's a product for the community and from the community. Many of the things that I showed you, it's something that we built together and found together with the community.
yeah, yeah, thank you so much for that because this is something which is so meaningful and we all need it. There's one more question. Is it good to implement the authentication by WebSockets rather than in get or post method?
Yeah. So I mean, if we talk about if I understood the question right, you're asking if you should implement authentication using WebSockets or REST in get/post. So we are comparing two protocols. One of them is WebSocket, and one of them is REST. So first of all, if you're implementing authentication on REST, I wouldn't use get. Why? Because many times some components in the middle between the client and the server would store the parameters that you send in the query. So if you like send the password as part of the query parameter, it can be very risky. Even if you go to your browser history, you can see all the like endpoints that you accessed, and if like someone else uses your computer, he would be able to see the password. So authentication should be done, like the sensitive information about authentication, like password, should be done using a post. And WebSocket is a different protocol. I mean, you can't really compare like WebSockets and like REST in terms of security, like comparing UDP and TCP. There are mistakes too that could be made in WebSockets, and the other mistakes that could be made in REST. If you follow the guidelines for WebSocket security and the REST security, you should be fine. And one of the guidelines is don't implement authentication on using get endpoints.
So do we have any solution for scanning vulnerabilities for APIs?
Yeah, I think we are also, it's like kind of, because we are like a open source community, like we can't really mention specific vendors, but definitely I would recommend you to go like with the modern solutions. Like there is a category of Dust. Many of the traditional Dust solutions don't really know how to handle APIs. But if you want to perform a successful pen test for APIs, I would recommend you to use IAST, not the more modern Dust. But yeah, IAST is definitely a better solution for APIs.
Yeah. Also, can you please recommend some resources or books towards API testing?
Um, so I don't think I know any specific book for API pen testing, but you are more than welcome to follow me on Twitter. I tweet I tweet almost every day about API security from different resources, different inputs.
So I've already shared the GitHub repo, the project details, and your Twitter handle so that they can follow you and they can get to know more about API security. I'm sure there'll be a lot of people who'll be coming back to you because this talk is recorded, and there'll be a lot of people who have not got the chance to attend today. They'll come back and refer it, and they will reach out to you. So if your DMs are open, I'm sure they're going to be flooded.
Definitely. And to be honest, I'm always happy to help people like about API security. I got my knowledge about API security just because I asked other people that know better than me. So feel free to ping me. I'll be happy to discuss and answer your questions.
Yeah, I think there's one more question. So one question, authentication is implemented using get method. Then in how many ways it increases attack surface for the application users?
So if we're talking about authentication, where the password is passed through a get, like a query param, and I mean like it's part of the URL, I don't think it's the most severe thing, but it's definitely not a good. It's not a good design from security perspective. The reason is that, like, let's say that you use some like API gateway in the middle, or you use like other components in the middle. They might save some of the logs for like your API calls. In this case, like if someone has access to one of these components in the middle, it can be like some type of reverse proxy or some log management, they might be able to see your password. I think it's also violates some GDPR. you definitely like should use HTTPS. Like you need to use encrypted connection with the API. But then even if you use encrypted connection, you still need to send the password on post to send it on get. It's kind of it's bad, and it mostly looks bad. Like if someone says that, it doesn't. I mean, it's kind of basic guideline for authentication. I wouldn't do it.
Any open source tool to check the vulnerabilities in APIs? We're going to be taking this as a last question.
Yeah, I think that Zap proxy definitely can be used for APIs. You just need to learn how to configure it. And there are some guides how to perform API pen testing for Zap. You can just Google it.
Yeah. Let me check questions, and I think we're almost done. So, everyone on the call, please feel free to reach out to Inon. His DMs are open, and he's very much responsive. So, if you have any questions, do reach out to him, tweet to him, and if you want to share a feedback, please do that. He'll be more than happy. So, thank you so much, everyone, for joining us today. See you all soon.